Hi everybody, and welcome to the CSAW HSF 2012 Finals walkthrough video. In this video we'll be exploring how to solve the 2012 CSAW HSF challenge and determine who was the killer and perpetrator that killed Stratos. To begin, all teams were handed a document with a link to a website, and we're going to go ahead and retrieve this document from CSAW, the cyber forensics community. So we're going to go to past CSAW challenges and 2012 finals. So in the document we're told some storyline regarding the Ouch Olympics and the Olympiad, and all the teams were directed to the website of the antitrust group, and the website was given here, http://anti.isis.poly.edu. So we're going to open this up and see what's there. So on first try, when I control click and try to open this website, I receive a web page is not available, can't contact the website type error. So earlier in the competition, one method that was used was giving websites IPv6 addresses instead of IPv4 addresses, and unless any team's infrastructure, their network infrastructure at their school or at home supported IPv6, the websites would show up as unusable. So knowing that, we're going to go ahead and attempt to connect to this website using an IPv6 tunnel or a proxy. In this situation, I'm going to use a proxy. Just going to Google IPv6 proxy and select the first one that comes up. And in this case, I'm going to copy this address and paste it in there. And now, as you can see, we are able to connect to the website, and we are greeted with the antitrust information. So I'm going to go ahead and play this message.
This message is brought to you by the antitrust. You thought we were gone. We are not. While you have been sleeping, we have been hard at work. We have now set our sights on the corrupt Mayan Olympics and so-called athletes. Nothing is sacred. Corruption is rampant.
So from this, we receive a message from the antitrust that they have been plotting, and it's directly a threat to the Ouch Olympics. We receive some storyline information that's critical. We find out that the antitrust is indeed responsible for Stratos' death. We see that this page is a method of recruitment for the antitrust group. They clearly have a image here that says "Join Us," indicating that they are looking for new members. However, more important to note that there is a link on the page called Pastebin. I'm going to go ahead and click that. Upon clicking that, I see that IPv6 proxy is telling me that this URL does not have an IPv6 address. So we're going to go ahead and switch back to IPv4. First, in order to do that, we're going to have to get the actual link. So we can put that in. And in order to do that, I'm going to right-click the page in my browser. I'm using Chrome, and view page source. And I'm just going to scroll down to the link. And in this case, ignore the IPv6 proxy, since that is coming from the proxy service. And go ahead and analyze this link, http://hsfpaste.isis.poly.edu/drop. So we're going to go ahead and navigate to this in this browser, hsfpaste.isis.poly.edu/drop. So once we navigate to this website, we see that there are a couple of files, and this looks like a Dropbox or a paste bin, as they call it. Just looks like there's a couple of files dropped here, and I'm just gonna go ahead and open a couple. File 3 looks like it's a file signature analysis website. Looks like it's indicating that teams should do file signature analyses on the files in this website. This is low-hanging fruit in the competition and is not necessarily important to figuring out who is the killer actually. So we're actually going to go ahead and focus on the important evidence here, which is nexus7.zip. This appears to be as a actual phone image, which is contained of a Nexus 7 tablet device. Although we do not know the owner, we're going to go ahead and download the image. open it up in Android AVD Manager, and we're going to analyze it to see what evidence it may contain, what information it might provide us about the owner, as well as who may have completed the crime. So as the zip is downloaded, we're going to go ahead and unzip it. And after it unzips, we're going to go ahead and open up our SDK manager. So in the Nexus 7, we have a AVD file and an INI file. Looks like that there is the path corrected on the INI file to home.android/avd, nexus7.avd. So we're just going to have to open our Android SDK manager. Now I am doing this on OS X, however the SDK manager is cross-platform and works on all operating systems. Okay, once the Android SDK manager is up, we're going to go ahead and click Tools, Manage AVDs to get the path of where devices are stored. And it says list of existing Android virtual devices located at users, my username, .android/avd. I'm going to go open up a Finder window and actually navigate to that. As we can see, we already have a image here. This is unrelated to this case. And we're going to go ahead and open this folder in the Finder and copy these two files in there. Okay. Now we're going to go ahead and refresh what we have in the browser. And as of right now, we have a red X indicating that the virtual device failed to load, and we're going to click Details to see the error. And it says that it's an unknown target, Android-16. What SDK Manager is saying is that the API 16 necessary to load this device is unavailable on the system, so we're going to download the API 16. We're going to accept licenses, and we're going to go ahead and install the API. What this will do is ensure that the APIs are available for the device to load. This seems to be an older firmware for Android, and therefore this requires additional installation. It's being unzipped and will later be installed. Now that we have the appropriate API installed, we're going to go ahead and click refresh once more. And now we see that Nexus 7 with the target name Android 4.1.2 with the API level of 16 is a valid Android virtual device. Start from a snapshot. However, we still want to save to snapshot, so it saves all the changes we make. So in this case, now we have a new window with a Android system booting up. Now that the phone is opened up and unlocked using the default Android swipe motion, we're going to go ahead and begin analysis. To start, we'll just go left to right from the home screen. Start with phone calls just to see if there's anything important in there that may be helpful. Check the history. Shows the empty call log. We're going to go ahead and return home and look at the contacts for a me profile. In this situation, there does not look like that there's a profile set up, and all these contacts look very generic. So we're going to go ahead and return home and check the messages. And in messaging, looks like there are no conversations. I'm going to go ahead and return home and open up the browser. As we open up the browser, there looks like there are a lot of tabs open here. See a village backup egavis at isis.poly.edu open. See a Debian 6 tar archive. Also see a someone signing up for Facebook using the ouch email. We also see a Google search for Google Crisis Response. This machine. So we see the village backup Now we're going to go ahead and analyze the history. Here we go. And click the bar, click history. So we see today's websites, and of that we're going to look at the village backup. We're going to see older history, which looks like there's browsing MIT OpenCourseWare, MathWorks, MATLAB, government apps, some government websites. And we're going to go ahead and click most visited. See if there are any saved pages on the website. Doesn't look like it. So from the browser we have the Debian machine. Now we're going to go ahead and see if there are any emails on the phone. Looks like something's loading up. Looks like that there are a couple of pages referred to in the emails. So it looks like Cabo 1 is showing a Facebook link. Go return back and see the first email from Ouch Olympics, which is the subject line. It looks like a web address, hsfrecords.isis.poly.edu, and it says that the Ouch Olympics should update the corporate site with the new records. So this looks like, since it's to himself or herself, this analysis can be made that the device belongs to Ouch Olympics. So we're going to go ahead and analyze the two new pieces of evidence discovered, which are this website, hsfrecords.isis.poly.edu. Now that we have the Debian installed in our VMware Fusion, we're going to turn it on and see that there is a village account for which we do not have the credentials. So try a random password, but it's the authentication failure. In order to bypass this, we're going to go ahead and boot the machine into single user mode. In order to do this, I'm going to go up to virtual machine, restart, and I'm going to go ahead and shut down. The process that we'll be undertaking will involve shutting down the machine, restarting it, giving it a different boot command. So during this window, we see that there are two options: to boot in recovery mode and in regular Linux mode. So we're going to go ahead and actually edit the regular Linux boot. Scroll down to the line using the arrow keys of where it has Linux and the root UUID. And we're going to append to that line, initialize init equals /bin/bash space RW. From that, we're going to use Control X and boot the machine. Now we see that we have a root shell, and from that root shell, we're going to type in passwd. For this will change the default root password, so I'm just going to set that. And now we want to actually change the password of village. So we're going to do passwd village and change that to whatever you guys would like. I'm going to go ahead and use password and update that successfully. And after that, I'm going to go ahead and restart the machine and see if this has been successful. I'm going to go ahead and restart. Now that we have reset the password for the village account, we're going to go ahead and log in with our reset password. Once we log in, we're going to be presented with Village Desktop, and from here we'll be going and actually looking for one file in particular in the user's downloads. This file is messages. It's a QDB SQLite file, which was used earlier in the competition, and we're actually going to pull it out into OS X for analysis. And in order to do that, we're going to use SQLite browser. So the next step would be to pull out the messages file. So I'm back here in my Mac OS X box, and I have SQLite database browser open. It's a GUI for reading QDB SQL files, and I'm going to actually open up the messages file that we have. And from here we see that there's a couple of tables on this database. We see there's a participants, we see there's a users, we see there's SQLite sequence, see messages as well. We can actually browse the data, and we see that there are, in table messages, there are messages, however we're unable to read them. They are encoded in a different language. However, actually if you drag out the subject line, you see that there is a link to hsfgames.isis.poly.edu. And this is a website that we'll be going to next for analysis. And we see here that there are users and participants. So we're going to go ahead and close this file, and the next point of analysis will be hsfgames.isis.poly.edu. When navigating to hsfgames.isis.poly.edu using a IPv6 proxy, the teams were presented with the following games: Lucky Sevens, Agent 8 Ball, Flip Card, and finally Blackjack. From this they were able to find a ledger, which was the goal over here, and they'd go ahead and click slots. And in this version from IPv6 proxy, the JavaScript and AJAX queries were stripped out because of the way the proxy works. Instead, the users were supposed to tunnel to the address and actually execute a AJAX call. So the job of the user or the team was to actually implement a AJAX call to hit all sevens in the Lucky Sevens game. And the code to do this is posted here and will be included in the resources. And what would happen is the number that was supposed to be hit would be inverted. So in order to achieve 6 sevens, there would have to be 6 ones inputted in the query. And this would be implemented in the JavaScript console. From here, there would be a congratulations message issued saying, "Congratulations, Stitch, you've won. Record entered in ledger." And then the ledger could be found here. When logged in ledger, thanks for playing. So this would demonstrate the gambling aspect of the antitrust and their corporation. Now we'll navigate to the new resource we found according to the email, hsfrecords.isis.poly.edu, and we get a webpage not available prompt error. So this indicates that the site either may be down or may be using a protocol that our browser cannot support right now, or our internet connection. Judging from the previous techniques used in this competition, would make a hypothesis that it is using IPv6 protocol, and in that case we're going to call on the IPv6 proxy to navigate to this website. So the IPv6 proxy, load up and type in hsfrecords.isis.poly.edu and click go. Now upon entering the site we see Ouch Olympic Records. We see some information including events, Olympic athlete participants, their dates, and country information. We see the information of the Ouch Committee, we see the Chief Executive Officer, we see the Chief Information Officer, Webmaster, and we see some information about Ouch. If we return back to the records and start analyzing this website, we realize that there are entries which follow a pattern. So continuing to analyze, we notice that the pattern does break for one of the participants, Frederick Gutierrez. And in this case, Frederick Gutierrez is missing a date. And in that date field there is a string with mixed case along with numbers and alphabetic characters. One loss of using this proxy is any team using the proxy would have stripped code in their preview. So for example, all the JavaScript and the styling of this page is not appropriately shown, nor is any JavaScript calls executed. So when a team would approach this and discover that there is a missing string here, they would have to highlight this string, and it would actually do a function call in the background. One other way of getting this, if a proxy was used and JavaScript was disabled, is viewing the source. And once in the source, it would be discovered that there is a hidden string. The team could easily see that it's a span ID with the function foo. So we could all navigate down and see that function foo is defined as a click function, and it would call the page request.php. So we're going to tell our proxy to call that page request.php in the root of the website. And we're going to go ahead and click enter. And now, as you can see, teams receive a page called Congratulations. To gain access to this resource, please raise your hand and request a search warrant from Judge C.SAW. From here, teams would receive a Windows 8 image, which would contain some malware and a TrueCrypt volume for discovery. After reversing and unpacking the malware, the team would receive a link to the ISISBay website. That website is available, so we can navigate there, the isisbay.isis.poly.edu. It's also an IPv6 site. Once at the isisbay.poly.edu, teams would realize that they are presented text files with MD5 hashes. From that, they would realize that there are files that have hashes which do not match hashes provided in a text file earlier throughout the competition and throughout various infrastructure, all throughout the preliminaries and the finals. The unique feature of these files would be the ones that did not match would contain a letter which would all combine together to lead to the password for the TrueCrypt container, which would be ice cream. Finally, from this point, the infrastructure is no longer available at the time of the creation of this video. Once opening the Windows 8 machine, teams were to unpack and reverse the malware present within it to receive the web address of the isisbay.isis.poly.edu, as shown in the previous clip. From here, the group of files would lead them to contain a TrueCrypt container password, and the password would be found as ice cream. This key would give them access to the TrueCrypt volume, and from here teams will discover a blackmail email message with the name Stitch. Cross-referencing this with HSF records and HSF Games Ledger, teams would deduce that the killer is Joel Fernandez. After this, teams would